Hey everybody, it's Bruce and the dog on the floor, and today we're going to be talking about NX. Specifically, we're going to talk about some of the different ways that you can make tensors. This video comes from the Ideas in a Great blog post. This is a great series from Sean Moriarty, one of the creators of Axon. And this series is basically tips about NX. And so this particular one is ways that we can create arrays or tensors. Now, if you're anything like me, you've been thinking in functional programming terms for a long time. But sometimes when you're working with NX, it can lead you astray. Instead of layering functions together in the usual functional way, which will create many intermediate objects, what you should often be doing instead is using the primitives of NX to create tensors in the correct shape and orientation in the first place. And we're going to talk about a number of ways to do so. As usual, I'm going to be working from a live book, and I've already imported NX. I've actually added the mixed dependency. And so I'm going to be filling out this section of the live book. This is a section, and I already have a couple of chunks of markdown here. So I'm going to drop in some Elixir. So the main way that you'll create a tensor is with the function that we've been using, nx.tensor. And just to refresh your memory from where we've come from, I can have a scalar type, and this is going to create a tensor that doesn't have any dimensions. This is so if I pass this to a shape, nx.shape, this is going to give me a shape, an empty shape, because it doesn't have any dimensions, right? And so you might say that this isn't very useful, but one of the things that you can do, so if I look at this individual function, so I'm going to run this much. I'm going to reevaluate this, and you can see that this is going to just build a typical tensor. And the arguments are some Elixir data structure and then options. Well, one of the options that we're going to use is type, and another option that we use quite frequently are the names of the individual dimensions. So if we want to create in NX some type of integer, but we don't want to pick up the native type, we could say type, maybe we want an unsigned, maybe an unsigned 8 to basically save in byte size or something like that. And so then I could create a tensor out of those things using a broadcast or something like that. So this particular mechanism is going to allow me to create a tensor from either some numeric type or some collection type. And typically the collection type that you're going to see is a list or a tuple, or a binary. Well, let's talk about the list, and then we'll go into binaries, right? So if I have a one-dimensional list with 1, 2, 3, you'll see that I pick up an additional shape here, right? And the shape is just working from the inside out, we would go from right to left. So the outside in, we would go from left to right. So if I add some additional brackets to this, saying that I have a two-dimensional data structure that only has one row, this is going to pick up that outer dimension of 1, right? And so I could add another dimension here quite easily. Oh, that's in the wrong place, isn't it? Okay, so I've added another dimension there. So I could add a further dimension here, and you can see that I'm just going to keep stacking ones here. And so what happens if I add another row here? 4, 5, 6. Well, this is just going to add another row to this particular dimension like that. So now I have two outer ones, and then two outer dimensions, and then I have the 2, 3 dimension that's in the highlighted section right here. right? So I can impact my type this way. I can impact the data structure this way. And actually, let's get back to a data structure that we can manage. Yeah, so now we have a form of 2, 3, and I can actually add labels with names, so I could label my x-axis and the y-axis. So maybe it's like this. Oh, this is going to be a list, isn't it? Yeah, I think that NX expects this to be a list like that, right? And so I have 2 potential y's and I have 3 potential x's, which is exactly what I want. So this is really an Elixir, what you would normally see an Elixir person thinking in terms of, right? And so I would try to layer function calls to actually build these lists in the middle. And since I'm working with very large data structures, sometimes creating those intermediate lists can be pretty large. And so what I'd like to do instead is use some of the primitives provided by NX to actually build the correct data structure in the first place instead of moving it around. And so one of the formats of data that I'm very likely to encounter when I'm working with data science is data that's created, that's in a file that has some type of a descriptor, but is in some format other than Elixir's native format. And to do that, I'm going to often use a binary to express those ideas. So here's what I mean. So maybe I have some number. Maybe that number is 1, 2, 3, 4, 5, 6, like that. And then maybe I have some type of format that I want. Right? So this is a binary, and I'm just going to put the number in there, and it's going to cram those numbers one after another straight into memory. And that's, in this case, it's going to build a string. But typically, what I do in if I have like a data set that's coming in, is I could be very specific using Elixir's rich Erlang foundations to describe actually what's happening here inside this binary. So for example, maybe this is of size 4 or maybe size 32, 4 bytes, right? And then maybe this is signed, and maybe these are integers, and maybe I could use big endian encoding or a little endian encoding, which basically describes where the most significant byte is. And this is going to produce something called a binary, right? So this is my binary. And so maybe what I'd like to do is take that data and dump it straight into a tensor that I can then reshape. So for example, what I'd like to do in this case is say nx.from, and then I'm going to pick up tab to get completion, and I get from binary, right? Just so to look at what this looks like, it's going to ask for the binary and then the type that I want to create, and then options to create it with. And the options, as you might expect, allow me to provide names, and the type, as you might expect, allows me to apply a type to this thing. So for example, maybe I want to pass it the binary, and I want to give it a type of maybe I want these to be unsigned 32s. Oh, and I don't want it to be helper in this case. And so, yeah, so you could see that I get a one-dimensional tensor with 1, 2, 3, 4, 5, 6. That's the number that I created in the first place. And I pluck those right out of the binary, but I can describe the rules for how I break that number down right here. And that's another way that I can create a tensor. And then once I have the tensor, I can reshape it. So for example, maybe there's a lot of data in there, and maybe I want to say nx.reshape, and maybe I want just a 1, 1 array or something like that. So You can see that I have a list of lists here. Now I have the two dimensions exactly as I have described them in my list here. So that's another great way to create a tensor. But these aren't the only ways. We talked about broadcasting a second ago, and very often what you want to do with numerical computing is create huge tensors that already have random data in them, or they already have ones or zeros in them for individual numeric algorithms. And that's what we're going to do next. Let's go ahead and broadcast. So all I'm going to do is do an nx.broadcast. And remember, the way that I broadcast is to specify some type of tensor here. But in this case, we're going to use a scalar. So maybe we want to build a template of zeros, and maybe we want to fill that out across a tensor with 3 dimensions where each dimension is of size 2. And so this gives me the dimensions 1, 2, and then 3 with the whole thing. And so you might ask, how do you specify a type here? Well, let me try to specify a type here. It's not going to let me, but let's find out why. So I could say type, and then I could do like an unsigned, maybe 64, like that. And it's telling me that the type isn't allowed here. But remember, this doesn't have to be a scalar. This can also be a tensor, and a tensor can have a scalar value, right? So I could say nx.tensor, and then I could specify the type here, right? So I could have a 0 and then a type of, say, signed 8, like that. And so you can see that I've specified the type just fine right here. And so I'm not limited to creating a tensor with the broadcast in one dimension like this. I can have a row that's repeated over the length of the tensor, or a column that's repeated over the length of the tensor. Both of those things will work just fine using the same techniques that broadcast gives me elsewhere. But this is a great way to create a basic tensor that has an initial value that where they're all the same. Typically ones or zeros or something like that. Okay, so the next way that I could create a tensor with initial values is with random numbers. And this is going to come in handy when I'm doing machine learning, because very often the algorithms that we're going to use for training perform better when they're seeded with a random tensor in the first place. So this is the markdown cell. So this is random. So I'm going to create 2 cells here for Elixir. There's 1, there's 2, and so let's say nx.random, and this could be a normal. This could be normal, but I'm going to provide a shape here. So maybe I want a 2 by 3. I'm going to let that fly, and you can see that I have random normal distribution here. Or I could have this could also be a random uniform distribution, so something like this. Okay, so the random uniform is going to look something like this, and maybe I just want a single dimension of 3. I'm going to let that fly, and you can see that this is going to take numbers within this range. Now I could also specify a range, like with a floor of 0 and a max of 5. And I can reevaluate this again. You can see that these are changing, right? And I can also specify a type. In this case, maybe I want unsigned 8s or something like that. And so it's nice to be able to create a tensor of random numbers for many of the types of algorithms that we're going to use, especially for machine learning training and things of that nature. So because if we start them in a random place, then the algorithms are often going to perform better than if they had started at zeros or ones or something like that. So what we've done is we've created tensors in a lot of different ways. So rather than use the traditional Elixir tools, for example, like stream repeatedly or pipelines of individual lists that build a lot of intermediate results, we used some data structures and some primitives to be able to create the tensors that we wanted right off the bat in the format with the contents that we wanted right at the beginning. There's one last capability that we'd like to be able to use, and that's the ability to count. And so we're going to do that next. Okay, let's drop a little markdown marker here. We'll tidy things up later. So the capability to count is built into a function called iota. So nx.iota. This is going to ask me for a range. And so I'm going to start with a single dimension of 5, just so you can get the overall idea that we're working with. Okay, so what this has done is created a range from 0 to 4, right? So what happens if we go to multiple dimensions? So I'm going to add another dimension here. So I'm going to say nx.iota, and then I'm going to say 5, 5, and yeah. So this is allowing me to count beginning at the beginning of the tensor, moving left to right or inside out, however you want to think about it. I'm counting from 0 all the way up to 24. So one of the things that I can do is specify the axis that I want to count along. And you can see where broadcast is going to come into play here. So I'm going to say nx.iota, and then I want to do a 5 by 5 again. And then I'm going to say count along the axis 1. This is counting on the inner axis, with the outer axis being axis 0, right? So if I change this to a 0, then I should see the counts go from bottom to top. And that's exactly what's happened. 0, 1, 2, 3, 4, right? So take a look at what we've done. So all of these things are using primitives to create tensors. So after we get through the initial few ways of creating the tensors, so we just have Elixir list here, we have a binary here, and then we have a scalar here that we're broadcasting. The rest of these techniques, rather than using functional primitives, are using NX primitives to create the data in the final form so that we don't create a lot of intermediate forms. The performance will be good, and it has the shape that we want, and it has the characteristics of working with chunks of data that we want. And that's really an excellent thing. For Bruce and the dog on the floor, this is Gruxio Learning.